Hey, grade 5. Now, as I've been going over concepts that we've also covered in class, I've had a few students ask me about long division and say they could use a refresher on it, so let's do that. Now, actually, the very first video I ever made back over 4 years ago now, as my first year as a teacher at Samuel W. Shaw, was about long division. So if you want to go back and hear an older description, as well as my white math teacher rap abilities, then check out the link to the old video that I'm going to put into the description of these. But that said, that was my first year as a teacher, and I'm much better at explaining things now than I used to be. So hopefully this video is useful to you as well. It's a little more clinical and it's more laid out, but it's also hopefully more direct and more comprehensive for the subject. So let's get started on that. Now I'm going to do two separate videos. The first one is grade 5 level. This shows us how to do long division and end up with a remainder. The second part, that's going to be a separate video and have this same intro, is a demonstration of how we can go even further, talking about using long division to get fractions or even decimals instead of remainders. Alright, here goes. Now before we start talking about long division proper, it's important to get some vocabulary out of the way. Now, I'm going to be using these terms as we go through the steps of long division, and it's good that we're all clear on what they are ahead of time. So there are three things that we talk about when we do a division problem. There's the dividend, which is the number we're splitting up into smaller pieces. There's the divisor, which is how many parts we're splitting it into. And finally, there's the quotient, which is what we get when we split the dividend into as many parts as the divisor says. It's the answer. So, dividend, divisor, and quotient. Those words are going to be important. Make sure you know which is which. And I'm going to be referring to them as we go.
All right. Now, long division is pretty simply a matter of starting at the biggest place value present in your dividend and working your way to the right each time you have a remainder. We're going to start by looking at a three-digit problem divided by one digit. But first we need to outline the way that you draw for long division. Now, normally you'd look at a problem like this. The dividend divided by the divisor equals the quotient. But when I'm writing a problem with long division, I use a different symbol. Let's draw it. It looks like this. Now this tells us a little bit of a different thing. I need to structure my problem in a different way to make this make more sense. Let's show where the different parts of the division problem go when we're using this bracket. First, I put my dividend, the number that's getting split up, inside the bracket. The number I'm dividing it by, my divisor, goes on the outside, and when I am finished, I will eventually have a quotient on top. This is how we're going to be structuring things from here out, so don't worry about these symbols right now. They can go. Now, I'm going to try a pretty big number divided by a pretty small number here. I'm going to start by drawing my bracket. The problem I'm going to try and answer is 867 is my dividend, and 3 is my divisor. Now, long division is just starting at the biggest place value present in my dividend and working my way to the right every time I have a remainder. So, the biggest place value in 867 is the hundreds. I need to start by looking at how many hundreds I can get if I split 8 of them into 3 equal groups. So, I start 8 divided by 3. Now, 3 fits into 8 twice. I can get 2 groups of 3 out of 8. So I put my 2 on top. I know I'm going to have 2 complete hundreds in my answer. But that's not all I'm going to have. I know there's going to be a remainder here. 2 times 3 is not 8. So since I won't have used them all up, I need to check for a remainder. How do I check for a remainder? Well, I just need to multiply what I just got by my divisor. and see what the difference is between that and my starting number. I got a 2. 2 times 3 is 6. Now I'm going to put that down below the 8, because now I need to check for a difference, and as the word difference implies, I need to subtract. 8 minus 6 gives me a remainder of 2 hundreds that I still haven't split up. My remainder, when I divide 8 hundreds by 3, is 2 hundreds. Now that I'm done with my hundreds place, though, I can move on to my tens. Those leftover hundreds aren't going anywhere. I can combine them. 2 hundreds is actually just 20 tens. If I pull these 6 tens that I already had down, now I can say I've got 26 tens that I can split into 3 equal parts. 26 is definitely a number I can divide by 3. How many of them? Well, if you know your times tables, you'll know that the closest I can get to 26 without going over is 8 threes. I know 8 times 3 is not exactly 26 though, so I'm going to have a remainder again. 8 times 3 is 24. So my 8 tens times 3 groups of them are going to be 24 tens. Now that means that those hundreds are completely gone. I'm done with the hundreds. Those are going to cancel each other out. And 6 tens minus 4 tens, I have a remainder again of 2 tens. Lastly, I'm going to bring down my final place, because those 2 tens are actually 20. I add my 7 ones onto them and get 27 ones that I can divide by 3 again. This will tell me how many ones I have in my answer. 27 divided by 3 is 9. Now, I do know my times tables well enough. I know there's no remainder here anymore. But let's double check here. 9 times 3 is 27. I subtract to see if there's a difference between what I started with and what I got. There isn't. I'm done. No remainder. 867 divided by 3 is 289. I need to go from my largest place value, in this case, the hundreds, split that up, and bring the remainder over to the next place the whole way down. Now we say the steps for this are divide, which gives us our number for our place, multiply, which gives us what our actual answer should be, subtract, which tells us the difference, and bring down, which combines the remainder from the previous place value with the next part.
All right, that's what's actually happening at each step. That means we can use the mnemonic DMSB. Now, if you watched my much older video, you'd know that there are a lot of different ways to come up with ways to remember those letters. But what they stand for us when we're actually dividing is divide, multiply, subtract, and bring down. Now, to follow those steps, we first divide the largest number in the dividend. Then we multiply what we got from that largest place value by our divisor. We then subtract the product from that place in the dividend to get a remainder, and bring down the next place so that we can start all over again with the next place in the sequence. D, M, S, B, and then possibly R. Repeat until you're done, at which point the R can be remainder. And that's it. That's long division. So this ends the grade 5 level portion of the long division work. But if you're interested in going a bit further and seeing how this applies to fractions, decimals, and getting rid of remainders and turning them into something else, then please check out part 2. Peace.